Assalamu alaikum, dear students. Today we are going to discuss the soil phase diagram, porosity and void ratio. Today is week 4 and lecture 8 of Geotechnical Engineering 1. So let's begin. So solids in the soil are basically organic matters or the fragmentation of rocks, different types of rocks which we discussed already. So they may be either made of organic matter or weathered pieces of rocks. Because they are in irregular shapes, so when put together these particles, they will form empty spaces between them. These empty spaces are called voids. These empty spaces may either be filled with water or air, or usually they are filled with both. Okay. The portions of solids, water and air and soil mass influence the property of a given soil. That's why it is very important to discuss the volume of solids, volume of voids and volume of voids which are filled with water to completely understand the properties of a given soil. So over here you can see the soil skeleton of a typical soil being idealized over here. So we have got soil particles which are of irregular shapes, and because of their irregular shape they form empty spaces between them. In this case the empty spaces are partially filled with water, shown in the blue color, and partially filled with gases, or generally typically we call it filled with air. So if we simplify and separate the volume occupied by each in a separate portion being representing each, this is known as three-phase diagram comprising of three different phases having solid particles volume, because solid particles are more over here, so we are imagining or visualizing them to occupy more volume over here, then water, and then the empty space is representing air. So just for sake of idealization we have separated them over here for our understanding, which will be used to determine the various important properties we are discussing in the coming slides. So we can think of constituents of occupying three different spaces as solids, water and air, as we discussed on the previous slides. So for sake of simplicity they are discussed as volumes and weights. The volume of solids in a soil mass is marked as Vs, which you can see over here, volume of water as Vw, and volume of air voids as Va. If we add all of three together, that will give you the total volume of a given soil sample. And if we combine the volume of water and volume of air voids, that will give you the total volume of voids, because voids are partially filled with water over here and partially filled with air. So if we combine them together, then it is volume of voids. For the simplicity, anything besides the volume of soil solids will be volume of voids, and volume of voids will be always comprised of volume of water and volume of air. For a fully dry soil, it will be completely volume of air, and for a fully saturated soil, it will be the whole volume of water. Now coming to the weight side, weight of the soil solids is represented as Ws, weight of the water is represented as Ww, and weight of the air voids is represented as Wa. Now in comparison to weight of water and solids, we can consider the air to be weightless. So generally volume of air voids is taken, weight of the air voids is taken as 0. So WA will be considered as 0. So the total weight of a given soil sample will comprise commonly of weight of soil solids plus weight of water. Unlike the volume, over here only weight of water and weight of soil solids only they matter, and weight of the air is neglected. So the total weight will be equal to weight of water plus weight of soil solids, and the total volume will be equal to volume of air voids plus volume of water plus volume of soil solids. Okay, so moving on, first important property which we are going to discuss in the following is the moisture content of soil. The moisture content is simply defined as the ratio of weight of water in soil to the weight of the soil solids. Okay, commonly it is expressed in percentage, so we multiply it by 100. Any ratio, if you multiply it with 100, that will give us the value in percentage. Otherwise, in numerator and denominator you have weights, so it will be unitless quantity. If you multiply it with 100, then you can represent it in percentage. Okay, so what we have over here, weight of water is calculated from here, and weight of soil solids is measured from here. So if you divide weight of water divided by weight of solids, you can get the ratio of weight of water with weight of solids. If you multiply it with 100, that will be known as water content, or commonly known as moisture content in many books as well. Okay, symbolically it will be presented as WW divided by WS. We will be determining this value for a typical soil in the laboratory as well, in which you will take a soil sample and then you will take its weight along with water in moist form. Then you will put it in air type oven at 110 degrees centigrade for 24 hours, dry the sample, and that will give you the weight of solids. Okay, so weight of solids minus weight of wet soil will give you weight of water. So weight of water divided by weight of solids multiplied by 100 will give you the moisture content or water content of that particular soil. In the coming lectures and also in geotechnical design, you will see that the moisture content is very important property, because the shear strength and compressibility properties of the soils are greatly affected by the moisture content. The higher is the moisture content in case of clays, the more problematic the clays are. So usually it is very important property to be considered to determine the soil behavior. Then coming to void ratio, which is represented with the small symbol E. Void ratio of a soil sample is simply defined as ratio of the volume of voids to volume of soil solids. Now coming to this side of three-phase diagram, to the volume side of three-phase diagram. Okay, previously we were working over here. So it is simply the volume of voids, which is the combined volume of air and water, okay, divided by volume of soil solids. So if you divide volume of voids divided by volume of soil solids, that will give you the void ratio. Now, as the name implies over here, that it is a ratio and not percentage, it is commonly not multiplied by 100. Okay, so volume of voids divided by volume of soil solids is represented as a ratio. Okay, and soils, if the volume of voids is greater than volume of soil solids, the value of void ratio can be greater than 1 as well. Okay, unlike porosity, which we will be discussing in the next topic. So you can calculate it like this as well. We will determine the void ratio of given sample in the laboratory as well, and you will be using this extensively in consolidation and settlement calculations as well. Okay, it can be rewritten like this as well, okay, because in laboratory you will be determining it using this procedure. Over here you can see volume of voids is also equal to total volume minus volume of soil solids as well, okay. So you can see over here volume of voids, because you will not be able to directly measure the volume of voids in the laboratory, so we will be measuring the total volume and volume of soil solids. So total volume, which is this, minus volume of soil solids will give you volume of voids. So volume of voids can be written as V minus Vs divided by Vs. So this is also the equation of void ratio commonly given in many books. So you may come across this equation, but for sake of calculation in the laboratory you will be using it in this form, okay. So it's very simple. So moving on. Now some discussion about void ratio. If the same soil is compacted and made dense, if you take a soil which is in loose form and you compact it to higher density, so what you are basically doing over here, you are reducing the volume of voids. So when you reduce the volume of voids, it will get into a denser packing, which you can see over here. However, the volume of soil solids will remain same over here. So in this case, volume of soil solids is in denominator and volume of voids is in the numerator of the equation, which means by compacting the soil you will be reducing the void ratio of a soil. So if you have a soil and it has a higher void ratio, it will automatically means that it is a loose soil and it's not compacted. And if you reduce the volume of voids, which automatically means that to reduce the void ratio, it will automatically means that the soil is in dense state. So in application, if we know the void ratio of the soil, we have better control or fluid conductivity, because if you have got less voids, less water will pass through that particular soil, which is known as fluid conductivity or permeability, which we will discuss later on. And particle movement through its pore will be also reduced, so erosion will be reduced as well. And also when you compact the soil, its shear strength and settlement properties will be also improved as well, which we will be discussing extensively in the coming lectures. So void ratio is very important property, which basically gives you the amount of voids in a particular soil at a given condition. Now coming to porosity, which is represented by small n. Porosity is also a property related to the volume of a given soil, which is represented as ratio of the volume of voids to the volume of soil sample. So unlike void ratio over here in the denominator, where it was volume of soil solids, it is the volume of the whole soil sample. So volume of voids divided by volume of whole soil sample is basically porosity. You can represent it by volume of voids divided by V, multiply by 100 sometimes as well. Sometimes it is expressed as percentage and sometimes it is written as ratio as well. As you can see clearly, the soil porosity, we don't write soil porosity ratio, so commonly it is sometimes multiplied with 100 as well, okay, unlike the void ratio. So void ratio was volume of voids divided by volume of soil solids. Porosity is volume of voids divided by the whole sample volume. Now over here you can see you've got two different types of ratios based on the volume, that is void ratio and porosity. However, in soil engineering, in geotechnical engineering, void ratio is more favored than porosity, which basically means that we use void ratio more than the porosity. The reason is that in case of void ratio, if you see, when you compact a soil or when you expand the soil, the volume of soil solids remains same. You are only changing volume of voids. Okay, so you get a better understanding in comparing loose soil with the dense soil, etc., because there is only one variable. So there is less uncertainty and you can easily compare the answers. While in case of porosity, the volume of voids is divided by the whole volume. So if you compact or expand the soil, it will change the volume of voids, but it will also change the total volume as well. Okay, so that's why, because there is only one variable in void ratio, it can basically give you a better understanding and a better comparison between the loose and dense states of a soil. So that's why we use void ratio more commonly than the porosity, and they are related to each other, which we will later on discuss in soil weight volume relationships. The next important property is degree of saturation. We know from our previous knowledge, which we have so far gained, that there are empty spaces between the soil particles which may be occupied with water or air. If the voids are completely filled with water, with pore water, then it will be considered as fully saturated soil. While if the volume of voids is completely occupied by air, it will be a dry soil. While if the volume of voids is partially saturated by water and partially by air, it will be, as the name implies, a partially saturated soil. So the soil can be under a different saturation condition from fully saturated to partially saturated and dry state as well, depending on amount of moisture or water present in the voids of a given soil sample. So degree of saturation is simply a ratio of the volume of water to the volume of voids. Okay, so volume of water and volume of voids. Remember that volume of water is basically a portion of a volume of voids or all. So if you have voids, the voids portion, okay, you've got solid portion, then you've got voids portion. So the voids portion, if it is completely filled with air, okay, then it means that the volume of water is 0. So when the volume of water is 0, then volume of water, if you put denominator is 0 divided by volume of voids multiplied by 100, which is sometimes represented as ratio, sometimes it is multiplied by 100 as well, because the ratio word is not mentioned over here, so you can multiply with 100 and present it as a percentage, or sometimes is ratio as well. So over here in this case, if it is ratio or multiplied by 100, the value will be equal to 0. So for dry soil, the saturation ratio or the degree of saturation will be equal to 0. Similarly, when all the voids are filled with water and there is no air, see over here there was all was filled with air, all the voids were filled with air. Over here all the voids volume is filled with water and VA is equal to 0. So in this case, volume of voids is equal to volume of water. So VW is same as VV. Okay, so if this is same as this, it should be equal to 1. Okay, because if this is 100 and this is 100 as well, 100 divided by 100 is equal to 1. If this is 50, this is 50, and 50 divided by 50 is also equal to 1. Okay, so this is the one. You can multiply it with 100 and present it as a percentage as well, or you can present it as a ratio 1 as well. So for fully dry soil, the degree of saturation will be equal to 0. For fully saturated soil, the degree of saturation will be either 100% if you are represented it as a percentage, or it will be equal to 1 if you are representing it as a ratio and not multiplying with the 100. And for partially saturated soil, the value will be between 0 and 1. Okay, if for example if the degree of saturation value is 0.5, it means that 50% of the voids are filled with water and 50% of the voids are filled with the air. So it will be like this kind of situation, that if the degree of saturation is 50%, then it means that these are all filled with water. Okay, so this is basically water and this is basically air. So in this case 50% of the voids are filled with water, 50% with the air. So degree of saturation, let's say if I call this hole as 100, then in this case 50% is filled with water. Okay, so it will be 50 divided by 100. Okay, if all is 100 and top is 50, then 50 divided by 100. So if you do that, that will basically give you the value as 0.5. Okay, so 0.5 is your degree of saturation in this case. So that is it for today's lecture. In next class, we will discuss the relationship between those various properties related to volume and weights. So if you know the one property, you can basically calculate the another property from that. So this is very, very important in the geotechnical engineering, those relationships. So in next class, we will be discussing the soil volume weight relationships. Thank you very much for listening. Good luck.